Somewhere in the woods of Connecticut in the summer of 1975, a child came home from an afternoon of playing in the backyard, and a tick was found embedded behind their ear. The family drove to the doctor. The tick was removed. The doctor examined the bite site, told the parents to watch for a rash, and handed them a small brown bottle of insect repellent. "Apply it to exposed skin before the child goes outside," he said. "Reapply every few hours." The bottle contained DEET. The doctor did not mention any alternative, because in 1975, there was no registered alternative that any physician in any medical school or continuing education program had been given reason to mention. DET was the answer. DT had always been the answer. DT would continue to be the answer that families' grandchildren are being handed the same bottle today, not a similar bottle, not an updated version of the same compound, the same synthetic chemical developed by the United States Army in 1944 to protect soldiers dying from malaria and dengue in the Pacific theater of a world war, registered for civilian use in 1957, marketed through the same retail channels and the same plastic bottles, is still the default answer at every pharmacy counter in America when someone asks how to protect their family from ticks. The tick that carries Lyme disease has, in the time since that Connecticut backyard in 1975, expanded its range from a small cluster of counties in the Northeast to cover most of the eastern United States, with populations now established in parts of the Midwest and pushing further west every season, as climate conditions extend the viable habitat of the black-legged tick beyond its historic boundaries. The CDC estimates 200,000 confirmed Lyme disease diagnoses per year in the United States. Many tick-borne disease researchers believe the true number may be 10 times that figure, given the rate at which Lyme disease is misdiagnosed as fibromyalgia, chronic fatigue syndrome, and other conditions that share its later-stage symptoms. The tick has become one of the most medically significant disease vectors in the Northern Hemisphere. And the answer on the shelf is the same answer that Connecticut family walked out of the doctor's office with in 1975. The alternative has been sitting in grapefruit skin for the entire time. Welcome to the vault. Tonight, we open the file on nutcatone, the compound that CDC scientists spent 6 years developing, that EPA registered in 2020, that kills ticks by exploiting a neurological system that insects have and mammals do not, and that most of the 200,000 people who will be diagnosed with Lyme disease this year have never once heard of. This story does not start with a laboratory, it starts with a cedar tree. For the Nuu-chah-nulth people of the Pacific Northwest, the insect-repelling property of Alaska yellow cedar was simply part of what the tree was. It did not require a press release or a pharmacy shelf. It required only someone to notice that insects avoided it and to remember what they noticed. The observation was passed forward through generations of people who lived in that landscape and needed to work in it during summer without being driven from it by biting insects. The grapefruit was growing in subtropical groves. The cedar was growing in coastal forests. The compound that is the same in both of them was sitting in both of them, available to anyone with a laboratory and a tick problem, which is exactly what CDC had. In the forests of the Pacific Northwest, indigenous peoples of the coastal nations had long observed that certain insects avoided Alaska yellow cedar. The tree carried a distinctive resinous smell that repelled biting insects that made summer work uncomfortable. Someone noticed. Someone remembered. The observation found its way into the seasonal practice of the people who lived in that landscape, carried forward as practical knowledge before any of it had a name in any scientific literature. 6 years of CDC research, EPA registration in 2020, and the tick spray aisle is still mostly catching up. The compound responsible for that cedar scent is called nutcatone. It takes its name from the Nuu-chah-nulth people of the Pacific Northwest, whose territory the Alaska yellow cedar dominates and from whose language the name of the tree itself is partly derived. The same compound exists in grapefruit rind, where it is responsible for the characteristic bitter citrus smell and taste that distinguishes grapefruit from every other member of the citrus family. The two sources, a coastal cedar tree and a subtropical citrus fruit, produce the same molecular compound through different biochemical pathways, in concentrations meaningful enough to be detected by the human nose in both cases. For decades before anyone investigated its insecticidal properties, nutcatone was used extensively by the food and fragrance industries. It is on the FDA's generally recognized as safe list for use in food products. Ben Beard, the CDC's deputy director for vector-borne disease, pointed out when the EPA registration was announced that nutcatone has been in common consumer products for generations. If you have drunk Fresca, Squirt, or any grapefruit-flavored carbonated beverage, you have consumed nutcatone. If you have worn cologne or perfume with any citrus note in the past 50 years, you have worn it on your skin. The compound's safety profile for human contact was established by decades of food and fragrance industry use before a single insecticidal study was conducted. This is the baseline, a compound already deemed safe for human consumption, already present in common beverages and fragrances, derived from a fruit available at every grocery store and a tree growing across the Pacific Northwest. being studied by CDC scientists looking for an alternative to the synthetic chemicals. That 50 years of public health experiences had taught them a significant portion of the population would not use reliably. Stay with me, because how nucotone kills ticks is the part that should have been in every conversation about Lyme disease prevention for the past 20 years. DT works by hiding you. It blocks the olfactory receptors that mosquitoes and ticks use to detect the carbon dioxide, lactic acid, and chemical signals that human skin and breath continuously release. A tick in a DT-treated environment cannot smell you. It moves on in search of a host it can detect. DT does not harm the tick. It confuses it. When the DEET wears off, the tick can find you again. This is why DEET needs to be reapplied. The mechanism offers no penalty to the tick for approaching the treated surface, only failure to detect a host. A tick that walks across DEET-treated skin is no worse off than a tick that did not. The compound has done nothing to it. It simply did not find you. Nucotone does not hide you. It kills the tick. The mechanism involves something called octopamine receptors. Octopamine is a neurotransmitter in the insect and arachnid nervous system that functions similarly to adrenaline in the mammalian nervous system. It regulates heart rate, muscle activity, and the insect's behavioral responses to external stimulation. In normal insect functioning, octopamine helps coordinate the flight or fight responses that allow insects to respond rapidly to threats. Nucotone overstimulates these receptors in ways that the insect nervous system cannot regulate or recover from. The tick's own nervous system runs away from itself, generating uncontrolled electrical cascade signals until the tick convulses and dies. CDC scientists and the journalists who covered the 2020 registration described it accurately as the insects twitching to death. It does not matter whether the tick is resistant to pyrethroids. It does not matter whether the tick's population has developed any genetic resistance to existing synthetic insecticides. Octopamine receptor overstimulation is not a pathway that can be readily evolved around the way single-site synthetic insecticide resistance develops. The tick's own fundamental neurotransmitter system is being turned against it. Here is what makes this mechanism remarkable from a toxicological standpoint. Mammals do not have octopamine receptors in the neurological sense that insects do. The specific receptor pathway that nucotone exploits to kill a tick is not meaningfully present in human, dog, bird, or fish neurology. The compound has what toxicologists call selective toxicity. It exploits a neurological vulnerability that is present in the arthropod nervous system and absent from the vertebrate nervous system. This is the ideal profile for any pesticide. The thing that chemists working on conventional synthetic insecticides spend careers trying to achieve, and it exists in a compound derived from the peel of a fruit. EPA reviewed this toxicological profile before granting registration and classified nucotone as non-toxic to humans, mammals, birds, fish, and bees. Not merely less toxic than DEET, not merely reduced risk. The EPA classification is non-toxic. A compound that kills a black-legged tick within minutes of contact through uncontrolled neurological stimulation. Poses negligible risk to the human applying it, the dog walking beside them, the birds in the yard, the fish in the pond at the edge of the property, or the bees in the garden. This is why CDC spent 6 years in federal funding developing it. This is why BARDA, the Biomedical Advanced Research and Development Authority, contributed contract funding to Evolva's development of commercial production methods. This is why EPA reviewed it and registered it. The compound was genuinely worth the investment of federal resources because the public health problem it addresses is real and growing. Tick-borne disease expanding into new regions, while existing synthetic repellents carry side effects that reduce compliance, particularly in the parents who most need to protect young children. And this is why almost nobody in the tick-endemic counties of New England, New York, Pennsylvania, Wisconsin, Minnesota, and the expanding Lyme Belt has heard of it. Federal registration and consumer awareness are different things. The distance between them is measured in marketing budgets, retail shelf agreements, and pharmaceutical sales representative relationship networks. CDC does not have a marketing budget for nucotone. EPA does not run consumer awareness campaigns for newly registered biopesticide ingredients. The information went into the Federal Register and the scientific press and waited there for someone with commercial incentive to carry it the rest of the way to the person who needs it. That person is still buying DEET at the pharmacy. Here is where the vault opens on something that should make you stop and ask who benefited from the silence. The chemistry that makes DEET effective at repelling ticks and the chemistry that makes nucotone effective at killing them both exist. Both are real. Both are documented. The question is not which one works. The question is which one ends up in the bottle at the pharmacy and which one ends up in a federal press release that the local news did not cover. DEET has been on pharmacy shelves since 1957. The supply chain that delivers it there, the synthesis facilities, the formulation plants, the distribution networks, The retail relationships built over 67 years, the packaging lines, the advertising budget, represents an enormous accumulated investment in a specific chemistry. The companies that built those supply chains have financial structures, employee headcounts, quarterly earnings expectations, and shareholder relationships, built around a product that a significant fraction of the outdoor recreation and suburban gardening market buys every spring and summer. Nootkatone does not come from a synthesis facility. It comes from grapefruit rind and Alaska yellow cedar oil at concentrations too low to extract economically at consumer product scale, without a production technology specifically developed for this compound. Evolva, the Swiss biotech company that partnered with CDC on this research, developed a yeast fermentation process that produces nootkatone in commercially meaningful quantities through engineered biosynthesis. The patents on this production process are jointly held by CDC and Evolva. Any company wanting to build a consumer product around nootkatone needs to license that process or invest in developing an alternative. Both paths require capital expenditure, technology transfer time, and regulatory compliance for a new production method, none of which is required by a DT manufacturer who has been running the same synthesis process for decades. This is not a conspiracy. Nobody gathered in a boardroom and decided to suppress the grapefruit compound. The federal government funded the research specifically to expand the options available for protecting the public from tick-borne disease. EPA registered the compound publicly, with press releases and press kits specifically designed to generate consumer awareness. The CDC published all of it. All of it is available to anyone who searches for it. What did not happen is that the information traveled from the Federal Register into the pharmacy aisle, the physician's office, the parenting magazine, and the school nurse's handout that goes home with children at the start of summer. That journey requires someone with a financial stake in making it happen. The companies with a distribution infrastructure to stock pharmacy shelves have DEET. The companies with nootkatone products are small enough that they do not have pharmaceutical sales representatives attending continuing education lunches, where physicians learn about new products. The gap between what the government registered and what you know about is the gap between what is publicly available and what someone paid to put in front of you. The result is that 5 years after EPA registration, 200,000 people will be diagnosed with Lyme disease in the United States this year. And most of them will have bought their tick repellent from a wall of DT products at a pharmacy counter, staffed by someone who was never informed that an alternative existed. Here is what you need to know to actually use this, and what the research says in practical terms. Nootkatone-based repellents at 2 to 3% concentration provide protection against ticks and mosquitoes for 4 to 6 hours per application, according to CDC-funded research, comparable to standard DEET products at 20%. Ben Beard stated explicitly at the time of the EPA registration announcement that nootkatone lasts longer than most natural repellents and as long as synthetic ones. The compound provides both repellency and contact kill. Most repellents do one or the other. DT repels without killing. Permethrin kills on contact but cannot be applied to skin safely. Nootkatone repels ticks and kills them on contact, applied directly to skin in a compound the FDA considers safe for food consumption. Having both mechanisms in something you can rub on your child is genuinely unusual. It smells like grapefruit. It will not dissolve the crystal of your watch or the frame of your sunglasses the way DEET does. It will not accumulate in pond water at concentrations toxic to the dragonfly larvae that eat mosquito larvae. It breaks down in the environment after application, rather than persisting for weeks, the way certain synthetic pesticides do. To find nootkatone products currently available, search for nootkatone insect repellent or natural grapefruit tick repellent. Look for nootkatone listed on the active ingredient label at 2% concentration or higher. Products listing it as an active ingredient have been through EPA's registration review for that specific formulation. They are available through specialty health retailers and online, at a price premium over conventional DEET products that reflects both the smaller production scale and the recency of the compound's commercial development. The child in Connecticut in 1975 came home from the backyard with a tick behind their ear, and a doctor handed the family a bottle of DEET. Their grandchildren in Connecticut in 2025 have the same backyard, the same ticks, and access to a compound the federal government registered 5 years ago. That kills ticks through a mechanism that leaves humans, dogs, birds, fish, and bees entirely unaffected. The compound that smells like grapefruit, that the Nuu-chah-nulth people of the Pacific Northwest knew kept insects away from cedar forests before the United States existed as a country. That the FDA has considered safe to eat for decades. That CDC spent 6 years developing and EPA registered in 2020. That most of the 200,000 people who will be diagnosed with Lyme disease this year have never heard of. The grapefruit was always there. The cedar was always there. The tick that causes Lyme disease has spread into most of the country. While the answer sat in a fruit at the grocery store, and the same bottle of DEET, a Connecticut doctor, handed a family in 1975, sat on the pharmacy shelf beside it. The only thing that did not happen was the part where someone with a financial stake in your knowing paid to put it in front of you. If this vault opened something for you, subscribe and hit the bell. Every like and every share preserves what they tried to erase. The next vault opens soon.